This week we have the pleasure of studying Leonhard Euler, who was a brilliant and prolific mathematician of the 18th century. So Euler was a Swiss mathematician who spent time in St. Petersburg, Russia, and also in Berlin. Now, as I said, he was highly prolific. In fact, his opera omnia, his collected works, consist of 84 volumes of papers, and mathematics journals were still publishing backlogs of his articles 50 years after he passed away. So Euler was not only one of the greatest mathematicians of the 18th century, but could be the greatest mathematician of all time. So Euler rose to fame because of his solution to something called the Basel problem. So you see the third bullet point down on the right-hand column. You see this sum of fractions, 1 plus 1/4 plus 1/9, etc., etc. So that is the sum of the reciprocal squares. And at this time, the study of infinite series was all the rage, and people were learning new things about these series all the time. And the famous Bernoullis, for instance, looked at this series and were completely befuddled by what it might add up to. It turns out that Euler, in the late 1730s, was able to solve this problem, and this is how Euler rose to fame. It turns out that the answer to this problem, that is, if you were able to add up all of these reciprocal squares, the result is something very surprising. It turns out to be pi squared over 6. And, you know, it's amazing that the number pi could creep into the answer of this question, of this problem. And we will be seeing in our reading this week exactly how that happened. So Euler rose to fame on that problem, and he went on to have this very illustrious career. And there are some contributions of his that perhaps you already know about. For instance, there's this famous Euler identity that says e to the I pi plus 1 equals 0. It's one of the most famous equations of all time because it involves some very fascinating numbers, I and e and pi and 1 and 0. Euler also presented a proof of Fermat's last theorem in the case n equals 3. Now, some of you might already know what Fermat's last theorem is. If you don't, well, in a week or so, we're going to be studying some things about Fermat's last theorem, so you will learn it there. Also in graph theory, Euler was the first to think about what are now called Eulerian circuits, where you have a graph and the object is to, traverse the graph where you only pass through each edge only once. He also made contributions to design theory. He was the first person to think about the idea of what are called orthogonal Latin squares. And also, Euler was sort of a congenial guy, maybe the opposite of Newton in this regard, a very sort of kind and congenial and humorous person, and also an excellent teacher and writer. And in fact, some of the calculus that was developed in the 17th century, Euler in the 18th century was able to write accessible accounts of these things that were rather friendly and, user-friendly and the like. So anyway, I hope you enjoy this week when we discuss Euler. In this module, there are a couple of videos by William Dunham, who's an expert on Euler, and he will tell us much more. So enjoy.